Simple Bayesian inference. There are many paradoxes in life, one of which is that we are born and habitually doing Bayesian calculations, but almost no one can calculate accurately. For example, children learn mathematics, even if they know the formula. They are always careless and always wrong. Not just one person, almost everyone is like this. We are always doing wrong calculations in the right way. What is Bayesian inference? In a word, we update our opinions, judgments, and beliefs based on new information, evidence, and data. Who doesn't? We are born Bayesian animals. Bayesian himself was a priest in Scotland in the early 18th century. Bayesian reasoning is essentially a variant of conditional probability, knowing that if A is B, then in turn solve the probability of if B is A. At this point, normal people have fainted. No one carries a calculator in their brain at all times. The sermon question is clear. This question is important to everyone and extremely useful. If there is a disease, the overall incidence rate is 1 in 1,000. The test for this disease has a very accurate rate. If you have this disease, the probability of being tested positive is 99.5%. If you don't have this disease, the corresponding probability of being tested negative is 99.5%. Now, the test found to be positive. What is the probability that the person concerned has this disease? Most people will answer 99.5%, or all kinds of random guesses. Someone did an experiment at Harvard Medical School, the world's most elite medical education and training institution, and found that most Harvard students can't count either. This question applies to any rare disease, except that the data used in the above situation comes from AIDS. The proportion of HIV-infected young men in China is 1 in 1,000, and the accuracy rate of HIV test strips is 99.5%. If someone tests positive, is he dead? Many people really thought so, thinking that their end was coming and doing many crazy things. In fact, there is no need. First, reveal the answer. If you are an ordinary person, even if you test positive, the probability of contracting AIDS is less than 1 in 6. If you use conditional probability to calculate, you have to have a calculator, which is big when you hear it, and Harvard Medical School students are folded here. I give a simple solution here. In the above example, a 1 in 1,000 incidence rate means that 1 in 1,000 people is infected with AIDS. And the probability of this person testing positive is 99.5, which is about 1. At the same time, the remaining 999 people who are not infected with AIDS will test 4.995 positives, which is about 5 positives, because the test results are 5 in 1,000 false positives. In total, nearly 6 people will test positive out of 1,000 people, but only one of them is actually infected. That is, if you test positive, the chance of contracting HIV is close to 1 in 6. It must be taken seriously, but it does not feel like the end has come. Bayesian reasoning is that we update our existing knowledge based on new information. In this, what we already know is that the incidence of AIDS among young Chinese men is 1 in 1,000. And at the same time, the probability of detecting false positives is new information. And when you put those two together, what we learned was that the probability of a person who tested positive having AIDS went from 99.5%, as you thought, to 1 in 6. From probability to frequency. When I did this above, instead of using probabilities, I converted them to frequencies. And the Bayesian inference suddenly became very difficult and very simple. Scholar Gerd Gigerenzer says in a new book, Risk Savvy, How to Make Good Decisions, Bayesian inference was already very simple. Not to mention Harvard medical students, even elementary school students, could calculate correctly. The key was to change the algorithm. Gigerenzer is the director of the Adaptive Behavior and Cognition program at the Planck Institute for Human Development in Germany. He and the Nobel laureate Kahneman are respectful and long-standing arguments. Kahneman is a psychologist who won the Nobel Prize in economics because he introduced many cognitive biases in human psychology into economics, which sparked a wave of behavioral shifts in economics. Kahneman believes that people have many cognitive biases which drive people to respond without thinking and do the right thing. Gigerenzer believes that these cannot be called cognitive biases. as if they are necessarily wrong. He suggests calling these characteristics of thinking the rule of thumbs, because they are generally reliable and occasionally make mistakes. They saved valuable brain computing resources and were evolutionarily advantageous, so humans are still like this today. He gave an example. Samuelson, the perfect representative of economists, wrote papers related to investment theory, all of which were capital markets lines, asset pricing models, and a bunch of mathematical models, but his actual investment was very simple: stocks, bonds, cash, etc. That is, in several asset types, it is enough to distribute funds equally, simple and effective. In fact, a similar strategy is recorded in the ancient Jewish classic Talmud. Divide the money into 3 equal parts, 1 to buy land, 1 to do business, and 1 to reserve. There is nothing wrong with it. If it is too small, the additional benefits will be limited. On the issue of Bayesian reasoning, Kahneman believes that humans are very bad at not counting. Ferenczi believes that the key is to adjust the algorithm. People get dizzy when they encounter probability, but they are very good at calculating frequency. Shortly after the advent of Bayesian inference, one of the greatest scientists of that era, Laplace of France, independently invented a practical version of the calculation method. The key point is to calculate frequency. The Bayesian in life. Let me introduce a Bayesian inference template that I modified and used on this basis. No matter what problem you face, you set 3 possible scenarios for what the future will be like: up, middle, and down, which correspond to getting better, unchanged, and bad, respectively. If you have a preliminary judgment, allocate the corresponding bases for the top, middle, and bottom. If you are a blank slate and don't know anything, give them the same base. Next, the trend of the thing itself will bring new information, and it may tend to be either up or down or down. In any case, you will add points to the corresponding base, and how much to add depends on the strength of the new information. My template is like this. The upper, middle, and lower base numbers are 33.33 divide 100 by 3, evenly distributed. The value range of each bonus point is from 1 to 5, the strongest 5 points, and the weakest 1 point. If you think the information is strong, assign a value of 5, and assign a value of 1 if the information is weak. In this way, no matter what, after a period of time, you have a lot of knowledge about it, which is definitely more reliable than every temporary head pat. You have a Bayesian brain that you carry with you. There are 2 requirements for Bayesian reasoning. The first is to clarify your existing judgments, and the second is to be honest about new evidence. The former is the starting point for judgments, and the latter is the basis for updating judgments. At this point, you should have thought that the market is a Bayesian betting system that uses transactions to resolve differences of opinion. Current prices correspond to current perceptions, and price movements represent revisions in perceptions. It is a living, massive, ever-changing Bayesian system. The reason why it is difficult for anyone to beat the market stably is that the market itself is an extremely effective reflection of real people's perceptions. By the same token, if you can gather a group of relatively reliable people to continuously bet on any judgment, then this group can be used to make predictions about anything. Going a step further, people have different degrees of reliability, and the reliability of judgments is also different. According to their respective performance, dynamically adjust their weights. The weight of reliable people gradually increases, and the weight of unreliable people gradually decreases. The weighted average forms a new judgment. The accuracy will be higher. In the end, you will get to things: a fairly effective judgment system and a fairly effective evaluation system for judges. The 2 feed back to each other and continue to improve accuracy. In fact, we do the same in life: close to reliable people, away from unreliable people. Attach importance to authority and despise delusions. The difference is that, being Bayesian in life, we are neither systematic nor precise and often miscalculate. Now, with the help of tools, we can do a lot better. Of course, never forget that both the Bayesian brain and the tool-built Bayesian exencephalon are just maps that help us navigate unknown terrain. No matter how many people work together to draw it, if the crust collapses, a planet hits the Earth, and the terrain is turned upside down overnight, Bayesian is no better than other maps to help us. It can't fight the black swan. It can't, because no one can. The second thing to remember is that prior judgments and new evidence are not always independent of each other. If you are already absolutely convinced that God exists, you will always find an explanation that makes you comfortable no matter what new information and new evidence comes up. True Bayesian men do not. They respect preconceptions, which are the starting point of all new knowledge, but are always ready to empty the stock to avoid falling into this trap. Unfortunately, there are not enough such people. Summary of this lecture. Today, we talked about a portable Bayesian inference tool, and we hope you can learn to use it. Let's review the usage of this tool. First, clarify your question. Second, list several possible scenarios and give them the same weight. And third, respect the new information and give each new information a different score of 1 to 5, which corresponds to the situation. Add the score to that situation. Continue for a while and you will get the answer. I was inspired by the scholar Gerd Gerenz's new book, Risk and Good Decision Making, which I recommend you take a look at for risk-conscious people. Everyone is in the process of constantly accepting new information every day. You are welcome to share today's content with your friends so that they can cope with new information. Thinking today. I'll leave you with an exercise question. Find a problem you care about. Use the Bayesian reasoning tool we introduced today. Insist on reasoning for a while and come up with your own opinion.